The next chapter we're going to be looking at is talking about triangles. And so at the beginning of this, we're going to talk about the angle relationships in a triangle and around a triangle. So before we can do that, we need to review how we classify triangles. Now there's two ways we classify them, by their side lengths and by their angle measures. So if we're talking by side length, we have your equilateral triangles where all the sides are the same, isosceles, which two or more sides can be the same, and scalene, which no sides are the same. If we're classifying them by angle, if they have all acute angles, then it's an acute triangle. If there's one right angle, then we have a right triangle. If there's one obtuse angle, we have an obtuse triangle. And then a word that's probably going to be new to you is equiangular, which means that all the angles are congruent. So we have equilateral means all the sides are congruent. Equiangular means all the angles are congruent. So let's go ahead and see about classifying some of these triangles. So number one, I noticed that it has a right angle, so this is going to be a right triangle. And the markings show that each side is a different length, so this is going to be a scalene triangle. So this is a right scalene triangle. Number two, I noticed that all the angles are acute. Whoops, going on number three. Okay, fine. All right, number three, all the angles are marked congruent, so it is equiangular, and all the sides are marked congruent, so it is equilateral. And then number two, we have all acute angles, so this is an acute triangle, and we have two sides marked congruent, so this is an isosceles. And then finally, we have an obtuse angle, so we have an obtuse triangle, and we have two sides marked congruent, so we have an isosceles. So the first thing we're going to talk about is the triangle angle sum theorem. Now this, when I've been talking to y'all, I've noticed all of you seem to remember that the angles of a triangle add up to 180, and so this is really all we're talking about here. So if I know two angles of a triangle, to find the third angle, I just add them together, subtract it from 180, and so I would, in this case, I would get 95. Now, one thing we've talked about theorems as being kind of things that we can know or can prove to be true about stuff. Another word that's going to come up is corollary. Now, a corollary is a theorem, but it kind of comes out of another theorem. So it's kind of like a sub-theorem. And so the triangle angle sum theorem has a corollary called the right triangle corollary, which says that the acute angles of a right triangle are complementary. And the way that you can prove this thing is that, well, you know that the angles of a triangle have to add up to 180. That's my triangle angle sum theorem. And I already know that one of my angles is 90 degrees. So if I substitute that in, and then get rid of the 90 there, I end up with measure of angle A plus measure of angle C is equal to 90. Well, the definition of complementary angles are two angles that add up to 90 degrees, and so therefore we've proven that the corollary here. Another corollary that kind of comes out of this is the equiangular triangle corollary, which says that if I've got an equiangular triangle, so all the angles are the same, then each angle has to be 60 degrees. And again, if you look about it, if all my angles are the same, and the angles all add up to 180 degrees, that means I've got three of them that are the same. So I take 180 divided by 3, and I get 60 degrees. Okay, next we need to talk about some terms you're going to hear. First, we have interior angle, which is the angle formed by two sides of a polygon. So angle 1, 2, and 3 are all interior angles. An exterior angle is an angle that's formed by one side of a polygon and the extension of an adjacent side. So angle 4 is an exterior angle. And then when we have an exterior angle, when a triangle, you also have what are called remote interior angles. And these are angles that are interior, but they're not adjacent to an exterior angle, so they're remote. An example I like to use a lot is if you've ever been out to DFW, you know that you can leave your car off in the remote parking, and that means that you're pretty far away from the terminal. And so you're far away from this point, and so remote interior means, okay, these are the angles that are far away from the exterior angle. That's kind of what we're talking about here. Okay, the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. So this angle out here, angle 4, we're saying is going to be equal to angle 1 plus angle 2. And we can actually take a minute here and just show you why this is true. Okay, I know that angle 3 and angle 4 add up to 180 because they're a linear pair. And I know that 1, 2, and 3 add up to 180 because they're inside a triangle. So I can set them equal to each other. And then I can subtract off this measure of angle 3, because it's in both of them, and I end up with the thing that we're trying to prove here. So the measure of angle 4 is equal to 1 plus 2. And then finally we have what's called the third angles theorem. And this one says that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. So essentially, if you've got this angle and this angle are congruent, and this angle and this angle are congruent, well, again, because the angles add up to 180, then the third angles also have to be congruent. So looking at some practice here, so I have an exterior angle and I have two remote interior angles. And I know that, again, so 140 is going to be equal to 105 plus angle 1. So measure of angle 1 is going to be 35 degrees. Now something's a little bit more complicated because we're going to start throwing algebra in here, but it's the same idea. Okay, I'm trying to solve for x and I've got I've got two remote interior angles and an exterior angle. So I set up the same way. My exterior angle is equal to the sum of my two remote interior angles. So clean it up there. Move some stuff around and I get x is going to be 26.